Let's start looking at lesson 1.5. Lesson 1.5 is parametric relations and inverses. Inverses is, we may not get to anything with inverses today, but inverses should be a little bit familiar. We've done those a little bit in Algebra 2, maybe even Algebra 1 before. Parametric equation, or parametric relations is brand new. To lead into that, let's talk about a relation defined implicitly versus explicitly. Okay. I'm going to tell you right now, you guys prefer relations that are solved or set up explicitly. Okay. The reason I say that, okay, so here's implicitly. A relation defined implicitly is a relation where the relation possibly function is not specifically solved for in terms of y. So it's x's and y's mixed in all together. If it is an explicit, then it's our type of equation that's y equal. And we usually prefer to work with equations that are y equals so much better. So implicit, it's not specifically solved. So this first example, we're just working with an implicit equation. Determine which of the ordered pairs, 2, -5, 1, 3, and 2, 1, are in the relation defined by x squared y plus y squared equals 5. And then is the relation a function? So, one thing at a time. How can I decide if the ordered pairs are in the relation? Plug it in. Okay? Yes, that's exactly what I'm looking for, is just the basic plug it in, meaning that I'm going to take the equation x squared y plus y squared equals 5, and the first ordered pair we're going to try is 2, -5, which means 2 is going to go in place of x, and -5 is going to go in place of y. So I'm probably going to write out more work than most of you would prefer. Sorry. So 2 squared times -5 plus -5 squared, and we're trying to ask ourselves, does this equal 5? So 2 squared is 4 times -5, -20, plus -5 squared, 25. So again, does -20 plus 25 equal 5? -20 plus 25 is 5. 5 equals 5. So we know that the ordered pair 2, -5 does work. What about the ordered pair 1, 3? We do have to do it for all of them. You don't assume just because one works, the rest do or the rest don't. You're trying it for all of them. What'd you say? No. And honestly, I'm writing more work than you guys probably would, so x squared y. So 1 squared times 3 plus 3 squared, and the question is, does it equal 5? 1 squared is 1 times 3 is 3. 3 squared?
Every time that I re-plug in the first one, I don't get 5 equals 5. I don't know what I'm doing wrong, but I'm doing something wrong.
Or if you're talking about this one.
The red one, not the blue one.
Oh.
I'm using a negative.
Okay, hold on. Time out. Let me finish this one here. Hold on. We're going to get all confused here. 3 plus 9 is 12. And does 12 equal 5 on this one? No. So what does that mean about 1, 3? 1, 3 is not a solution. Are we okay with that one? Now, Isabel, you got caught on the last one?
I've plugged it in like 30 times now, and I keep getting not 5.
Are you remembering that when you square a negative,
It becomes positive again. Wait, oh, I got 10. I didn't get 5.
okay, mistake found, right? Okay. And you guys all smile and nod and agree because you guys all do that same mistake too, right? I graded on tests a lot. Okay, can we try the last one now? So again, it's x squared y plus y squared equals 5. This time we're checking to see if 2, 1 works. 2 squared times 1 plus 1 squared, does it equal 5? 2 squared is 4 times 1 is 4 plus 1 squared, which is 1. Does 4 plus 1 equal 5? Yes, 5 equals 5. And so what's that mean? That 2, 1 is a solution. Okay, so the bulk of this problem was determine which of the ordered pairs are in the relation. So we determined 2, -5 and 2, 1 are in the relation. We determined 1, 3 is not in the relation. And did you guys remember the other question? Is the relation a function? Okay. So do we know what this graph looks like? No, we don't. And it's not y equals. We could not easily make it y equals. That would be a complicated task, actually. So the best bet is to think about your xy pairs, right? Which xy pairs were in this relation? 2, 1, and 2, -5. What do you know about 2, 1, and 2, -5? They have the same x values. And if it is a function, each x values maps to exactly one range value. Here we have an x value that maps to 2. So this is not a function.
Know that it's not a function. I have to do any of them.
Possibly. What are you suggesting?
Just the twos from like the same axis.
Well, you'd have to know if the 2, -5, and 2, 1 work in the relation. Yeah, you're going to have to know if they work because right there, just giving ordered pairs, if they don't work, they're not going to affect whether it's a function. So, okay. And I will say that when you see a y squared in an equation, that often causes a problem. I hate to say always, because as soon as I say that, we're going to find something that does work. But y squared often causes a problem with being something, whether it's a function or not. So, okay. Let's talk about relations defined parametrically now. Okay. This is a little bit different. But relations defined parametrically are relations where both elements x and y of a relation are defined in terms of a third variable, which is called the parameter, and they usually use t. An example of a parametric set of equations is this right here, where we're going to be working with an example 2. Notice there's two equations. One is an x equals, the other is a y equals. They are both in terms of t. So you have x equals t plus 1, and y equals t squared plus 2, 2t. Okay, this is a parametric equation. Looking at it as is, it's hard to tell what that equation is. It's hard to tell what that's going to look like. And so we're going to work with it a little bit and learn some things about it, so to speak. So first thing we're going to look at, A asks us to find the points determined by t equals -3, -2, -1, 0, 1, 2, 3. So if they want us to find the points, what are they asking me to find? What are points? Yeah, ordered pairs. Okay, if we're talking a point, like a point on a graph is an ordered pair. So they're giving me a t value, and they want us to find the ordered pairs. So the x, y values. I'm going to set up a chart, is what I'm going to do to keep myself organized. I'm going to put part A over here to the right. My chart is actually going to have 4 columns. I'll kind of make the columns as I go. The first column is going to be my t's. And so it's a very skinny column because we don't really need a whole lot with it. Did they tell us the t's to use?
Yeah.
Yeah, what t's did they tell me to use? What she said, right? Okay. So no magic on the t's. They told me that they want me to use -3 to +3. The next column is going to be my x column. And it says in order to find x, we're going to have to do t plus 1. So I'm heading, you can just head it x if you want. I'm heading it as x equals t plus 1 just to kind of help us remember. My next column is going to be my y column. How do we find y? T squared plus 2t. And my last column is going to be just putting it all together. So when we put it all together, we're going to have x, y ordered pairs. Can you do the math with me? T is -3. How do I find x? Add 1, right? I'm not going to write work down for all of them, but I will for the first row or two. -3 plus 1 is -2. T is -3. How do I find y? Now to find the y, it's -3 squared plus 2 times -3, right? But again, you don't have to write work for any of them. I'm just trying to on the first one or two. So -3 squared is 9. 2 times -3 is -6. So 9 minus 6 is 3. So what's my ordered pair here? -2, 3. See how that works? Okay. So now, what if t is -2? Okay, and -2 plus 1 is -1. What if t is -2 and we're trying to find y? -2 squared, which is 4, plus 2 times -2. So 4 plus -4 is 0. So my ordered pair is -1, 0.
You know what's the draw graph like this?
Depending on what they ask, yes. I can't remember what they ask. Okay, plug in -1, and I'm done writing the workout. For x, if you plug in -1, 0. -1 plus 1 is 0. Plug in -1 for y. You end up with -1 squared, which is 1. 2 times -1, so -2. 1 minus 2 is -1. Ordered pair? 0, -1. Put in 0. 0 plus 1 is 1. 0 squared plus 2 times 0? 0. Ordered pair? 1, 0. Put in 1. 1 plus 1 is 2. And 1 squared plus 2 times 1. 3. Ordered pair? 2, 3. Put in 2. 2 plus 1? 3. 2 squared plus 2 times 2. Ordered pair? 3, 8. And put in 3. 3 plus 1? 4. 3 squared plus 2 times 3. 9 plus 6, 15. Ordered pair? 4, 15.
What else is there? -2, -1, 0, 1, 2, 3, 4.
You were hoping, huh? Oh, you're looking at the x's.
Yeah.
Okay. I had the y's on the brain when you said that, so. Okay, that's part A. See how we did that? They gave us the t's, you're plugging them in to find x's and y's, thus your ordered pairs. B, which part is B? Okay. B is find an algebraic relationship between x and y, and then they're asking us, is y a function of x? We're trying to find an algebraic relation. We're trying to find an equation. Okay? So, we'll hold that thought. Okay? We'll come back to that in a moment. But let's find the algebraic relation. So if we want to find the equation, we were given these two equations, yes? If we're given these two equations, our job is to combine those two equations into one equation that just has x and y. So we want to eliminate that parameter of t. So, any thoughts on how we can do that? We have two equations. They both have a t in them. We don't want to have a t. We just want an equation in terms of x and y. Well, we can't set them equal to each other because they're not equal to the same thing. If they're both equal to, like if we could get them both equal to t, we could set them equal to each other. Although what happens, I picked the easier looking equation. What happens if I take x equals t plus 1 and solve it for t? Okay. We're solving this for t. Subtract 1, subtract 1. Aiden says t equals x minus 1. If t equals x minus 1, what could I do with that? Plug it into the other equation. Okay, so let me write a note off to the side here. First of all, what did we do right here on the first step? We picked one of the equations and we solved it for t. Okay, I picked the x equation because it was much easier looking, right? So we solved it for t. And now what are we going to do? We're going to take that and we're going to plug t into the y equation, or I should say the other equation. So my y equation is y equals t squared plus 2t. So every place I see a t, I'm replacing with x minus 1. So y equals, instead of t squared, I'm going to say x minus 1 squared, plus, instead of 2t, I'm going to say 2 times x minus 1. I agree. Hey now, I agree. I agree. My hand and pen don't agree for some reason, but my brain agrees with you. Okay, am I okay now? So it's t squared, so x minus 1 squared, plus 2t, so 2 times x minus 1. Okay, clean this up, and you have an algebraic relation that I can deal with. How do we do x minus 1 quantity squared? FOIL. So x times x is x squared. Outsides and insides are each minus x, so minus x and minus x, minus 2x, minus 1 times minus 1, plus 1. Distribute the last part, plus 2x minus 2. Clean this up, and I have,
Why is it minus 2x?
because we foiled. And when
I was
you,
thinking that 2x was the one for the other.
no,
I hate that so much.
the foiling.
Yes. I never remember.
Yep,
to do
you've
that.
got to get that middle term in there. Okay, so we had x squared here, minus 2x plus 2x cancel. 1 minus 2 makes it minus 1. So you have the algebraic relation y equals x squared minus 1. Now, the question that I didn't answer yet, because I wanted to do the algebraic relation first, is this a function?
Yes.
Okay, why yes?
There's no two domains the same.
Okay, so if you look at the x, y ordered pair list, none of our x's were repeating, correct? And were the x's ever going to repeat? No. Okay, what's another way to tell me that yes, this is a function? Okay, graph. What's this graph look like? Y equals x squared is a parabola. What's minus 1 do to it? Down 1.
Oh, I don't see those mixed up.
And okay, but in all honesty though, if you went up 1, left 1, or right 1, does it matter if you made that mistake? It's still a parabola. It still passes the vertical line test, right? Okay, so C said to graph the relation on a coordinate plane. Well, you can graph this one of two ways. First of all, we can graph a parabola and shift it down 1. Or, do we have some ordered pairs we could use? Yeah. you end up with a dot at 0, negative 1. You end up with dots at 1, 0 and negative 1, 0. And you end up with dots at 2, 3 and negative 2, 3. And so thus, a parabola scooted down 1. Okay, tomorrow I will continue talking about inverses. For those of you right here, if you're not here, you're going to have to get with me. The inverses are something we talked about back in Algebra 1 and Algebra 2. So a lot of it should be decently familiar. Not too bad. E-learning, don't forget to turn that in at some point, please.